Hello, my DevNation friends. Welcome to another Tech Talk. And today we have a very special guest. As usual, we have my friend live from Germany. He's a brilliant engineer and an awesome speaker as well. So let me introduce you to Gunnar. Gunnar,
Hey there.
welcome.
Hey, Enzo, thank you so much for having me again. I'm really excited to be here.
Oh, it's always a pleasure.
Yeah, awesome.
So, Gunnar, the stage is yours.
Wow, okay, that was quick. Cool. So then let's kick it off right away. Yeah, thanks again for having me. I'm really excited to talk about this topic because you all are like, witnesses of a premiere. It's the first time I'm going to talk about this. So I wrote a blog post about this project, JfrUnit, but I haven't spoken about it yet. So it's the first time and you're getting to witness it. But so bear with me. If something doesn't work out, you know where it's coming from. So the idea is to talk about continuous performance regression testing. So what does it mean? Well, we want to talk about how we can identify if we have, something got worse in terms of our performance. So less requests, our application can process less load, and we want to identify those things, and we want to find out where this is coming from. So that's the objective, or let's say those are the objectives. To break it down a bit, so we want to talk about how we can go about this, how we can implement such performance regression tests using JDK Flight Recorder and JfrUnit, and I will explain a bit what those projects are. We will talk about how we can use another great tool, JDK Mission Control, to analyze those regressions which we have identified. And lastly, we will see how we can go about producing JFR events, and we will see what it is, from external third-party libraries, which we cannot control, and how can we go and produce events from those using another tool which is called JMC agents. So that's a list of objectives. Let's see how far we get. A few words about myself, so you know who's talking to you today. I work as a software engineer at Red Hat. I'm the engineering lead for a project which is called Debezium, and that's a tool for change data capture. So this means it gets change events out of your database and sends them to Apache Kafka. There's a few other things I'm involved with. I'm contributing here and there to Quarkus, which I'm sure you've heard about. I've been the spec lead for Bean Validation 2.0. And quite a few other open source projects going on the side, one of them being JfrUnit. So that's like a side effort of mine. And if you're curious what I'm up to and new releases and so on, I would suggest you follow me on Twitter. All right, so let's get right into it. And well, if you think about performance tests, there's a challenge there. And this is, you are interested in finding out what is the throughput of my application. So how many requests I can process at the same time, or what's the latency? So how long does it take to process a specific request? But now if you think about it and set up tests for those metrics, you will realize that they are prone, or they are subject to the environment where those things are running on. So it depends on what kind of CPU do you have, or how many cores, right? Maybe you have a very powerful laptop, and then your application runs on just a 2 CPU kind of Lambda set. Or it's the other way around. Maybe you have not such a powerful developer laptop, but then this runs on a 48-core machine in production. And now, well, if you want to do performance tests, well, you need to be as close as possible to this production environment. Otherwise, your metrics in terms of throughput and latency, they would be off. So that's a challenge. And well, usually it can be hard to get such a production-like environment. So that's the first challenge. And then also it's just subject to other loads which are happening. So let's say you run something on CI. Well, there might be other CI jobs running at the same time. And then, well, whatever kind of performance metrics you derive, they're just not reliable because, there's this other load. It takes all the CPU, and you cannot really conclude anything from that. So that's a problem with performance tests, which are based on the actual metrics you're interested in, like throughput or latency. So what can we do about it? And this is where JfrUnit comes in. So the idea there is you don't measure those metrics themselves, but instead you measure other metrics which impact the performance of your application. And the idea is those impacting metrics, they might be more stable. So let's say something like memory allocation. So if your application suddenly allocates much more memory per request than it used to do before, this gives you an indication there might be a performance regression here because, well, allocating more memory, it means more things are happening, and this is something to look into, right? And, well, this memory allocation, this is a stable rate. So if your code doesn't change, this should be stable. It doesn't depend on the environment where this is running. on. So that's in a nutshell the idea of JfrUnit, and we will see how this works in more depth later on. Now, how do we get those metrics? Via Flight Recorder. So this is something which comes with the VM. I will explain it a bit. And this is the source for our change of our events, in this case, metrics. And well, if we compare those metrics, let's say memory allocation, and it's much more than we expected, and much more than it used to be, well, that might be a performance regression, right? So that's the idea, and you run this as JUnit tests. And then, well, you can use JDK mission control to dive into this and analyze what's going on. So that's, in a nutshell, the general flow of going about this using JfrUnit. So let's talk about some of those tools which we are having here in the mix. And the first one is JDK Flight Recorder. And this is a tool, I believe, I mean, it's getting more known now, but I still believe it's much less known than it should be, much less used than it should be. So it's a brilliant tool. It's open source since OpenJDK 11. So if you are in Java 11, and even if you are on the current or latest 8 builds, it has been backported. So you have the open source JDK Flight Recorder, and you can use this. And this is really cool because, well, it allows you to do all the things like monitoring, getting metrics out of your JVM. So it's built into the JVM, and it is also designed to be very efficient. It has a very low overhead. So you get those metrics like allocation rates. You can do things like profiling your method invocations. You can analyze logs. You can analyze different thread states. All those kinds of things, really, garbage collection. And you get this based on this framework, which is baked into the JVM. So really, this is a great thing. And well, you can use those built-in events. So there's a ton of events which are built into a Flight Recorder. They are just coming with the JDK for free for you. But then you also can add your custom events, and we will see what this means. So you can create JVM events, JFR events for your own metrics based on your application-specific needs. And this always meant to be always on. So you actually can keep this running in production, and then you would do something which is called like a continuous recording, and this would be running all the time. It would essentially keep the data maybe of the last 30 minutes, something like that. And then if you perceive something is wrong with your application, you could take a dump from that, and then you could analyze the data from the last 30 minutes from your production. So this is super useful. All right, so that's Flight Recorder, and I believe there was a session on DevNation before, so I'm not going into much more depth here, but that's what Flight Recorder is. Now, as I mentioned, there's tons of event types, and there's this nice page which you can see here. It gives you an overview of all the event types, and with each new JDK version, new event types are added. So it's hard to keep track of them. So I recommend you this page, and you can see what JFR events exist and what they do. So that's a pretty cool thing. Now, the other tool to consider is OpenJDK Mission Control. So this is essentially a client which allows us to, well, control those JFR recordings. So we can trigger, or we can start recordings. We can, take a heap dump from a running application, those kind of things. But more importantly, we also can use Mission Control to analyze those recordings and visualize them and see what actually is the data is about. So that's, this is the tool you use to actually gain insight from the raw data. So that's pretty much what I had in terms of slides. So now let's put those things in action. And by the way, Edson, I don't know if there's any questions, let me know, right? And we can try and answer them. All right, so let's see. What do I have? I have an application, and that's a basic CRUD application, a to-do manager. It's built using Quarkus stack. I know using the Quarkus stack. I know you have heard a lot about Quarkus here, so I'm not going to touch too much on that. And I'm going to use JfrUnit to identify a few performance regressions which I built into this, and we will see how we can identify them. But first of all, let me do a quick hello world so you see how this works in general. And this is, as I said, you use plain JUnit tests. So, and I already put this annotation here, JFR event test. So this is just for JUnit 5. The hint, this should be processed using JfrUnit. And now I just implement my test. And what I'm going to do there is I add this annotation enable event. And this tells me which event I would like to track here. So I want to keep track of garbage collections, let's say, and I also want to keep track of thread sleep events. So just for the sake of the example. And now I go and write my test code. And now in this case, I'm just triggering a garbage collection, and I'm also going to sleep a little bit for 1 second, let's say. And now I would like to assert the JFR events which correspond to those things, right? So let me do this. And I already have this member here, JFR events. And this is my container, which provides me a view on all the JFR events which are emitted here. So what I need to do first is I need to await all the events. So this happens asynchronously. And this means I need just to have this kind of barrier to make sure I have actually consumed or received all the events which have been triggered before. And now what I can do is I can, assert there. So I can say something like assert that events, and there should be contains. And then I can say I would like to have an event of this type, JDK garbage collection. Let me try that, and also let me assert the other one, thread sleep, and I also can assert on specific names. So let's say here, with I know this attribute is called time, and I'm expecting this should have a value of 1 second. So let's see. Okay, so let's wrap this actually. And now let's run this. Run as JUnit test. And I hope this passes. And now, it does run this code. It starts the recording in the background. And, well, this test is green. And so just, you see, it actually works. So let me just, change the event name here. And now there shouldn't be any event with the name garbage collection 1, right? So now I would expect this test fails. And exactly, that's what it does, right? So it's telling me that. So this is, in a nutshell, how you would go about asserting JFR events using JfrUnit. So you do something, you do this barrier call, and then you assert the events which have been collected. So that's the basic idea. Now let's see and do something more meaningful with that. And let me come back to this Quarkus application there. And I have a few tests here. And let me first run you through this a little bit. So what I'm interested in this test is, what I'm interested in here is the memory allocation. So I would like to make sure that my, a specific request of this application, let's say get to do, that this does not suddenly allocate more memory than I would expect it to do. So what I need to do for that is I need to establish some kind of baseline. So I need to figure out what actually is the expected value for the allocation here. And this is something I'm doing once in this method here. I print it out, and it tells me, okay, this kind of request, I do it in a loop because there's some warm-up effect. But then per average, I'm expecting this method, which I'm invoking here somewhere, execute request. Let's see, it's invoking this to do get API. And this should allocate a specific amount of memory. So that's just to establish the baseline. And now let me run this actually test here. And this takes a bit. So let me start this up there. Let me run it, JUnit application. We can take a look there. And now, again, I'm doing this warm-up thingy. Then I do another couple of iterations. And actually, let me just stop this once more. I want to cut down the iterations a little bit here because otherwise it's taking too long. So it's more reliable or more stable with more iterations. But for the sake of the example, I can, cut it down a little bit. So let me do this. And now what I'm doing here is, so I'm, invoking this REST endpoint of my application, which is started here in the background. And I'm allocating all the events which are about object allocations. And for that, I enabled those 2 event types, object allocation in new TLAB and object allocation outside TLAB. Would be too much to explain what is that. In general, it just tells you, those events, they tell you how much memory your application allocates, or how much memory in terms of object bytes. So this test is running. And I would expect this to fail because I have this assertion here. So essentially what I'm doing is I'm summing up all the allocated bytes from all those events. And now, based on this baseline, which I created before, I would expect that per request, this is below 33K, okay? And now this assertion failed, and you see it's a bit small, but let me do this. Not that way. It's told me how to zoom, and I did it wrong. I forgot it. Oh, no, I can do it. Hold on, there you go. So you see it a little bit, okay? It's off by factor 10, right? So I was expecting 33K, and actually it's 380K. So this test, or this application, is allocating 10 times more memory than I was expecting it to do. And now, of course, the question is, well, is this a problem or is it not a problem? So that's something to find out. And now, how can we go and analyze this? And this is where mission control comes into the picture, because what JfrUnit also does is it creates a recording file for me, so from the actual test execution, and I can examine that. So let me go there to my command line, and if I look at the target JfrUnit, I have all those recordings, and it's from a few previous tests before. But this one, that's the one I'm curious, or I just created the allocation regression. Okay, so let's take a look at that, and open it. And I'm opening this in mission control. And now, well, I can take a look there. And I know I'm expecting something here in the TLAB allocations, because that's what I was interested in. And this is telling me how much memory got allocated. Okay. And I see here this particular thread, executor thread 1, this allocated 1 gigabyte. So the vast majority of objects were allocated by the thread. So let's take a look there. And what I can do now is I can zoom in here a bit. And I can take a look at the stack traces, essentially, where those new TLABs were created. So they are like a sampling which tells me this is where memory was allocated, or objects were allocated frequently. And I can take a look there, and all those stack traces, they look pretty similar, right? So I step through here, and I see it's pretty similar. So I take a look there, because apparently this particular call stack, this tends to allocate many objects, many objects. And the question is, why is it doing this? And what I'm seeing now here is, okay, it has this Jackson data there. So let me go there, the Jackson object mapper. And now I know this application, I've built it, and I'm surprised because I wasn't expecting the Jackson mapper to be used like this. And also I have this REST assured thing there. So this is interesting. So and I can analyze this a bit. And in the end, I would see, okay, this is actually my method there, my web resource, right? My to-do resource, REST resource. So this is which is triggering all those allocations. And now, well, I can take a look there, right? So for that, I would go to my application again and to-do resource. And now let me open this method there, get with allocation regression. And now this is telling me, oh, this is what is going on here, right? So apparently now somebody on the team, it wasn't me, somebody else on the team, changed the code here, and they added this invocation of another service, the user service, using REST assured. And obviously, that's not a good way for invoking such another API. Now I would maybe refactor this, maybe use another HTTP client. Maybe I would decide I should not call this other REST service in such a way to begin with. But I found out by starting from this increased memory allocation, I found out, okay, this thing is happening now, and it may cause a performance regression in my application. So that's the idea. And let me take a look at the time, and I can show you another thing. So I will skip one example because I feel I'm a bit behind time, but I've got another example, and this is about SQL statements. So the example which I'm not going to show you is I also could assert on I/O, which I do with my database. So again, the idea is, let's say I have this to-do request here, and it's, I do a get to-do, and this loads a to-do from the database, and I'm expecting a certain amount of I/O in terms of bytes, which is loaded from the database. And now if I'm suddenly loading much more, well, again, it would be a potential regression, and I would look into this. Now, what's interesting there is I would also like to know what are the SQL statements which are triggering such a database access. And now, well, how can I do this using JFR? Because, well, right now, the library I'm using here, Hibernate, it does not produce JFR events itself. So I don't have a handle to get my the SQL queries which are produced by Hibernate via JFR. It's not there yet. But there's another nice tool which is called the JMC agent. And the JMC agent essentially is it instruments your application and injects code which then emits events for you. So that's what I'm going to do here. And this is configured via an XML descriptor. And here, well, now I need to know a little bit the architecture of that. But in my case, I know all my queries, they are sent through the database to the database via this eggroll connection pool. So I know all my database traffic, essentially, it's coming through this prepared statement wrapper, if it's a prepared statement. So that's what I'm essentially targeting here for my instrumentation. So I'm saying this prepared statement wrapper class, if its method execute query gets invoked, well, then I want to want to emit a JFR event. And well, the payload for the event, it should be a field from this class prepared statement wrapper. So in this case, wrapped statement. So I took a look at this class. I know it has this field, wrapped statement. So I want to emit this one, or the string representation of this also as into my JFR events. And now what I need to do is I need to run my application using this agent. And just to tell you how this is done, I'm attaching this Java agent. It has the configuration there, and then now this will modify the code of this prepared statement wrapper class to produce a JFR event. So let me run another test where I'm using this. And in this case, let me first run it. Run a JUnit test. Again, it's invoking this to-do API. And I have established this baseline. So I'm expecting this essentially. If I do a get to do, I'm expecting this to produce a single SQL statement, just a single select. So that's my baseline here. And now this test is failing. Well, it's kind of expected for me now, because well, it's telling me, in this case, I'm doing like 10 iterations, and in this case, it's doing 6 statements per iteration. So, instead of 10 overall, it's doing 60 overall. So it's doing like 6 times more SQL statements than I was expecting. And it's even telling me already what the statements are. So it's even part of the message here, because I get this from the JfrUnit representation. But again, I can also load this into JMC mission control. So let me do this quickly. And now in this case, it should be the SQL statement regression one. So let's see there. We open that. And now in this case, as this is a custom event, there's no bespoke view in JMC here. Instead, I just have to go to the event browser, which shows me all the events. And there I have my custom Hibernate events now. So I see all those prepared queries here. And now I could take a look and see what are those statements, where are they coming from? And in my case now, I'm pretty quick to see, okay, this looks a bit like a n+1 select kind of issue, right? So for each to-do, it's also loading all those to-do details. So this is what I deduct here. And then again, I can take a look into the call stack, and I can see where this is coming from. And I would take a look there. Somewhere should be my method. And here you go, to-do resource, and now, well, very suitable the name get with SQL regression. So that's my flawed method, right? So let's take a look at that one there to see what's going on. In the to-do resource, where's it? To-do resource, and get with SQL regression. And here I'm seeing now what's happening. So I have now, for the sake of the example, I load another to-do class, to-do with details. And this one here, it has this extra lazy collection to all the to-do details. And as I'm iterating through the details, it's triggering one select per detail. And obviously, I would like to optimize this. I would try and do a fetch join or whatever, so I avoid this all those statements to be executed one by one. So again, in this case now, I'm using JfrUnit, and it allows me even to do assertions based on events which are injected into this external code. So Hibernate doesn't produce those events yet, but I can take JMC agent to produce events on my behalf from Hibernate, or in this case, the connection pool, which is, I think, pretty cool. So that's what I had in terms of the demo. Let me look on the time. Yeah, I think that's good. So let me just go back to my slide set, and I have that here. Can skip that one. Yeah. Just briefly, so what I hope I could bring across, well, we have very robust tests here, right? And we also have a very fast feedback cycle. So something like the number of statements or the amount of I/O or this memory allocation, if I test this in my IDE, as we've seen, I get very quickly feedback. So I don't need to run a performance test on a separate environment, or maybe even finding out about the regression in production only. I get the feedback right away in my IDE, and it's independent from the particular machine. So that's pretty cool. But I guess you have seen that you need to have some pretty good understanding of the application and what is going on there, right? And you need to be able to decide, okay, maybe this increased allocation, it's for a good purpose. So maybe this service call there, it's a good thing, and that's something I want to, so I'm ready to pay this allocation. And it doesn't mean, it doesn't increase my latency maybe too much, so I'm fine with that. So that's, just if such a test fails, it doesn't mean something is wrong. It's more like this is a hint for a potential performance regression. So that's very important to understand. And also, you cannot identify all sorts of issues. So let's say you have some sort of locking going on, and maybe this only shows up under some sort of high contention. So many requests coming in at the same time, and only then you would suddenly have this contention on a lock. So that's something you could not identify using this testing approach. And also, well, if it's a database-based application, very often performance issues are with queries in the database itself, right? So let's say you have a bad execution plan. Well, this is, again, something you would have to identify using other tools. So in that way, JfrUnit complements other performance testing approaches, right? So I would not say it's a replacement, but it's an addition. So you can use this to identify performance or potential performance issues early on, but you also should have, of course, other means of going about performance tests in place. So that's JfrUnit, JMC agent. So that's a very nice project, as we have seen from the mission control umbrella project from OpenJDK. So this is really cool, and you can very nicely use it together with JfrUnit. And well, just on a side note, I recommend you definitely move on beyond Java 8 because, well, you have more JFR events. It starts up much faster and all kinds of goodness. So this is really just a general call to action. Don't stay on 8. Move on. It's worth it. You have tons of new and useful things there in the newer JDK versions. One thing in terms of a potential outlook. So, I mean, what we have seen right now, JfrUnit tells you about the current state, and maybe you can identify a regression there. But let's say you have a scenario where your application actually improves. So if you remember, I have those 33K memory allocation, which I was expecting. So maybe I've done some improvements, and now this goes down, and it only allocates 20K. So my test still would pass, or would good, but then maybe again I have a regression then based from that. So it goes then back from 20 to 20K, 25K. And I still wouldn't know this because my assertion still is with 33K. So what I need to have some sort of overview about the historical evolution of those values. And this is where this project Thorium comes in, which is another project from the Red Hat performance testing team. They do those projects like Hyperfoil, which is a performance benchmark suite, I would say, for microservices, and this Thorium tool, which is from the Hyperfoil umbrella. It is meant for keeping historic values. It's like a repository of historic measurement values. And now if I would combine JfrUnit with Thorium, I could have those historic trends, and I could apply some sorts of signal processing maybe, and find out if I have some regression, maybe also going on over a slower time, right? So a bit like the frog who doesn't hop out of the pen. If I have a regression which goes on slowly over many months, but then taking a look at the data, this would maybe tell me about this. So this is something I would very much I would like to explore for sure. A few resources. So about JfrUnit, so this all is, of course, open source, Apache 2 licensed. It's there in GitHub. As I mentioned, this was the first talk ever I was speaking about it, but there's a blog post on my blog about it, so you can read about that. There's a nice blog post about a JMC agent. Definitely recommend to check this out. And I have here just another link to an earlier DevNation Tech Talk about JFR and this project called Container JFR, which takes the flight recorder and makes it usable in containerized applications which you run on Kubernetes or OpenShift, for instance. So that's resources, and I believe that's it. Yeah. So Edson, I got that's what I had. I would be happy to answer any questions if there are. Otherwise, people can find me via email or Twitter, and we can, of course, discuss also later on.
Yes, Gunnar, we do have questions, and thank you very much for this awesome presentation. And some people are asking for the link to the slides. So what I suggest is that I shared your Twitter link. So if you can follow Gunnar on Twitter, he'll be posting the link to the slides shortly after the session.
Yes, so I will also share, by the way, the examples. So there's another repo with the examples. So I will also share that people can also try it out what they've seen today.
Awesome. So we do have some questions. And the first one is from Alexander. What's the structure of the JFR event?
Yeah, that's a good question. So let me go back. I have one example there. And so this is, for instance, how this garbage collection event looks like, right? And there's a few general properties, like in this case, start time, and I think name, I believe those are, or duration, those are common properties to all the events. But then you have attributes which are specific, right? So in this case, garbage collection event. So you have a GC ID, you have a cause, which in my case was, well, I triggered it via system GC, but you could have other causes, the sum of all GC pauses. So those properties, they are specific to the event type. And now you would see what's there if you go to this list with all the event types. So it tells you which are the attributes for each of the events. And by the way, don't be fooled by this representation. So this is just a visual representation. The actual format, it's a very effective compact binary representation. So that recording those events doesn't take up much disk space.
Awesome. And now Alec is asking you, how do you do regression? Do you store events in external files or database and compare?
Yeah, so this touches on this notion of a baseline, right? So let's say I have my memory allocation test there. So essentially what I would do is I would run this method here once. And I'm just printing out the actual values. So I run this API call 100K times in a loop, and then I print out how many bytes per request were allocated. So that's my baseline. And I just memorized it. And in my actual test, I am asserting against this value here, right? So maybe I should have made this a constant or something. But here, this value here, 33K, this is what I derived from running this baseline method here once. So that's how I identify if I have a regression.
Awesome. Next one from Alec. For given recording, how do you connect it to the particular version of source code and test that generated it?
Yeah, that's good. You would find the recordings in the target directory of your application, right? So that's a regular Maven application. So I have a POM file, I have a source and target folder. Now I run the thing, and I could also run it, of course, via Maven, Maven verify. And now once this is done, I would see those recordings under target JfrUnit. So for each test method, I have a specific recording file, right? So I have, let's say, this to-do resource SQL statements test. So I have, the one method which I had to demo the regression, and then I have another one for this method which just created the to-dos in the database. So I would have it, as part of this local workspace. And of course, well, the source code is there, right? So this is how it's matched. And if you were to run this on CI, you would, I guess you would know the, the git SHA of the checkout, and then you could correlate this with the data in the CI workspace.
Mm-hmm. And Alexander is asking, could it replace JMH micro benchmarks, or we should have both?
Oh, you definitely should have both. So I think, those things go together. Because you would use JMH to really understand where there's a bottleneck in your application, right? So, something you want to see what's the latency or let's say what's the latency of a specific method. So that's where you would use JMH. And so, the tools, they complement each other.
Mm-hmm. And we are almost in the top of the hour, so we have time for one last question from Carlos Pacheco. What tool made the storage chart? Was the chart built from multiple JMC recordings?
Yeah, so this was unfortunately not yet from a real recording. So this is coming from this tool, where is it? Horium, right? So I have the URL here. So just in a nutshell, Hyperfoil, that's a performance benchmarking tool for testing your microservices. So like, what's the latency of your requests? And you can do it in a distributed way. So that's pretty cool. And Horium, that's a sub-project of Hyperfoil, which provides you such a repository to keep track of historic performance measurements. And I just put a screenshot here, so it's not live data from any JfrUnit tests. But what I would like to do is I would like to integrate those tools, right? So my JfrUnit tests, they could run, they would produce the actual value for, let's say, the memory allocation or the database I/O or the number of SQL statements. And then they would invoke Horium, put the data there, and then I would have the historic data, and I could look at the trends over a longer period of time.
Awesome, Gunnar. Thank you very much again for this amazing presentation. And remember, you are always welcome here in the DevNation Tech Talk. And I hope to see you another time soon.
Absolutely. Thank you so much for having me. It was a pleasure. So thanks everybody for tuning in. I hope it was interesting. And yes, Edson, will be my pleasure to be back with you anytime.
Awesome. Take care.